Hello and welcome to the task Bezier Spline. In this task we are adding multiple Bezier curves together to create a big spline. In the lecture we saw how to do the C0 smoothness Bezier spline, which just adds multiple instances of the curves together. But in this task we are going to introduce C1 and C2 smoothness. So the first derivative of this spline will be continuous and the second derivative as well. Here in the task description, it explains about the mathematics on how to calculate the constraints, how to keep the spline smooth in the first and second derivative. For example, for the C1 smoothness, we need the shared points to be in between the second to last and the second points of the first curve and the second curve, respectively. And here we can see that if we have multiple curves together, then the shared points have to be in between the P2 and Q1 or Q2 and R1. And C1 smooth curve should be more smooth. So if you compare this image to this image, then this is much smoother. And here also explanation on how to do the C2 smoothness as well. So download the code and we can go over this here. So in this practice, we only have two files. We have the regular index, the HTML file, and we also have the main.js, the JavaScript file, so we don't have any shaders this time to modify. And on the load, we create the canvas container for our canvas, and we also have the status container. So if we see what is happening right now, it's just a black screen, but here at the bottom, there's this text here, there's a test and C1. So you can use arrow keys. If you go up, it's a random curve, and then it's a test curve. So test curve is always the same random curve. You use the random number generator to create random points, so the curve will be random. And if you use the left and right arrow keys, then you can switch between C2 and C1. And here is the key listener as well for this. So here is the function to get the random control points. Here is the function to get the test control points. So those are fixed, as you can see. Then we have a function to create the spline. So this will be one of the main functions that we will implement. But we also have two other functions to create spline C1 and create spline C2, which both called the spline function, create spline function. And the idea of these create spline functions is that in here create spline 1, spline C1, we will change the values of the points so that the created spline will be C1 continuous. And same here with C2, we will change the points in the array and then give it to the create spline function, so we get the C2 continuity. And finally, there's a draw function. In the draw function, there's also a task that we should scale all the points on X or Y axis and see if anything unexpected happens. So let's get started with the implementation of create spline. And the main objective of this create spline is to create the spline. We want the spline to be this object 3D type variable or a global variable that has three collections underneath. First collection is the lines. So the lines between the control points. The second collection would be the points themselves, so we can illustrate where the points are. And finally, we want the container for the curves. Let's follow the comments. So the first thing is, if not already created, then follow these steps. So let's create the if statement for it. So if not created, let's create this line object. And if it's null, then we do the following things in the comment. Store this somewhere. Yeah. So it should be like this. We can actually indent it. And there should also be the else clause when we want to update the vertices, not create a new one. And finally, we have to return the spline as well. and we want actually to return the spline object. So can remove this. And this actually is not a variable yet, so we should create the variable here as well. And now we can start creating this spline object. So spline object should be an object 3D, just a regular 3GS object. Create a new one. And first, let's create the line mesh that has the vertices as points. So name it lines. So what should it be? Let's go to the documentation of 3GS and search for line. Maybe there is something about lines. So objects are the things that inherit the object 3D. A line, so there are line loop, and line segments. So let's go to the line. This is nearly the same as line segments. The only difference is that it's rendered by using the line strip, which is what we actually need. So you can, as we can see from the example here, it only needs a material, line basic material, and it also needs points. So currently it's 3 points, but we have points as the argument of the function. And those points are given to the regular buffer geometry, and then the line is created. So let's create the lines first, and be a variable, and let's also rename these because we will create more materials and geometry in this function. We don't want to mix them up. So let's first create the line material, and that should have this definition here. So I'll just copy paste it, and here I can set the color to anything I want. So I would give it the yellow color for now. And now the line geometry as well. And here we wanted to make the buffer geometry. In the example, set from points is used. We want to use this function as well. Very convenient one-liner. And that should do what we want it to do. So now we have a line. And here below is store this somewhere and reuse the created object next time you want to update the vertices. And we then use it here. So the spline object, well, the spline object is the spline, isn't it? So we are already storing it. You can do it there. These comments are actually for the next block, but this should be this is the root object that we want to manipulate, so we should add lines to it. If I add the lines to it, and then return the spline, we are already returning it. So in theory I should see lines. So yes, I see the lines between my control points, but if I change the control points from test to random, nothing changes. That's because this else is empty, so we need to update the lines when we change the points as well. Currently we just create the object and then we leave it be. So one thing we didn't do is we had to name this lines object lines, and this will be useful because we want to acquire these lines from this object in this S block. So name equals lines, spline object, and get object by name, and we can use the name lines. So lines, and we can get the geometry of the lines, and use the exact same function that we used here, set from points, to set the new points. There's a semicolon missing. So now, when updating vertices, do not forget to geometry vertices need updates true. So it looks like we also need to do that as well. Oh, yes. So now if we go and press up, we can see that the random points will actually update the spline, or the lines rather. Now we can repeat this process for points as well. So we should use the 3.points. Let's go to the documentation for that. And that's also under objects. So it takes in the buffer geometry and material. So default new is the points material. So you should use the points material for that. Let's create the points. Point. So it will use firstly the point geometry and then points material. Points material will actually be exactly the same as the line geometry. Points geometry will be exactly the line geometry because we use exactly the same points, but the material will be a bit different, but we can still use the same structure, so it will be points material, and now we use this type instead. So it will be points material will be new 3.points material, and we use the same color yellow. And now we can add the points to the spline object. I guess this is the comment for this area. Okay, but we also need to name the point because we want to change it as well. It will be the points. But if I go to the tests, you can see that it changes, but the points don't change yet because I haven't I haven't written the code for it here, but I can do it now. So I can get the points object from the spline object and use the get object by name. And repeat exactly the same thing that I did with the lines. There is an error. So why I don't see the points now is because I have this points variable, but if you remember correctly, the points variable is exactly the same name for the argument of the function. So instead of using points, I should rename it to something like control points. So control points. And here's all. And here. So now this points is not this points. Let's see now. So yeah, now I can see the points. And if I update, the points also update correctly. And finally, the main part of the spline will be the curves. So this will be actually an object 3D because it will have many line objects underneath it. So let us create curves. Object. And here add as many empty line objects to it as needed. So that we'll do in a for loop. Create the line mesh based on sample points. Yep. So this will be in our for loop. And let us think about this for loop for the moment. For each curve, there will be 4 points. So 1, 2, 3, 4, and that's the whole curve. So to create all these curves correctly, we need to sample 1, 2, 3, 4 then 4, 5, 6, 7, then 7, 8, 9, 10, 10, 11, 12, 13, 13, 14, 15, 16. So we have to do this for loop. And if we think about it, this will be shifting by 3. So in the first iteration, we take the first 4 points, and it will be 1, 2, 3, 4. So the 1 is the first I, so to speak. Then we use the 4, 5, 6, 7, and the 4 it will be the second I, so it will be 1 plus 3. So the step will be 3. And how many iterations there will be? There will be as many until we get to this last line, which will be the 16 minus 3, so it will be 13. 13 will be the last index that we want to iterate over. So let me use the for loop, and I will be first 0. So the 0 is here. I used in my explanation the 1, but let's use 0 because the points start from 0. And I should be maximally, so how it should be the points length minus 3. And then finally we increment I by 3. And now we can define the body of the loop. So let's get our control points. So we need 4 control points at each iteration. I'll start with C1. It will be the points array, and then we will get it at the index I. So that will be our first control point. And I can repeat this for all of my control points. So C2, C3, and C4. But now I have to increment the I by 1, 2, or 3. So now note here, this is I plus 3, and at the next iteration, this will be exactly here as well, the I itself. So this will be the shared point. Okay, but now we can create the Bezier curve from this. But how do we get the Bezier curve? We should go to the 3GS again, the documentation, and we can see that at the extras/curves, there is a cubic Bezier curve and the cubic Bezier curve 3. So if we look at them, we see that this is for the 2D version and this for the 3D version. There are also quadratic Bezier curves, which only require 3 points, but for us we need 4 control points. So we can just copy this to get the curve. And instead of using these vectors here, we will use our control points. So C1, C2, C3, and C4. So now the curve is inside this function, the definition. We want to get points from this. And here in the documentation, we see that we can use the get points function. And then there's the number, how many points we want. So curve points. And get points. And for now, I will just query 20 points. I think this will be enough for the task, 20 points. And then we can repeat what we did in our line. And create lines from these points. So instead of using the points, we use curve points. And we also should rename this. So curve geometry. And actually the material can be shared between all the curves. So it will be curve material. And here we want this to be white or some other color other than the points and lines, because we want this to be distinguishable. And we can use this material as well. So now this line should have the curve in it. And we should add this to our curves. Add curve line. And if I go to our example, there should be something, but there isn't because I haven't added the curves to our spline object. Object add and curves. So now, yeah, now I have the curves. These are white lines, white curves rather, between the points, control points. But if I update it, the curve doesn't change, but everything else changes. That's because, yet again, I haven't implemented the changing algorithm here. But we can do it quite easily. So should name the curves because I want this to be accessible. And the name of the curves. So now I can query this from our else block. Spline object, get object by name, and it will be curves. Now I should update this by using the new version of points to repeat this process here. But I don't want to change the material or the geometry. So the generation of the line itself, we don't want to do, we just want to do the update of the line. So let me copy this for loop and then I'll start changing it. So firstly, we don't need the geometry. And we don't need to add anything either because we have already added it. But here, curve line, we should get this from the curves itself. So how do we get this? And if you remember, we started the first point here will be 0 index, then it will be 3 index, and then it will be 6 index. So we should get the curve line by accessing the children at the end index I divided by 3. Because if it's 0, I divide by 3, I get 0. If it's 3, I divide by 3, then I get 1. 6 divided by 3, I get 2, and so on and so forth. So it will go through all the curves. And everything else should be same except these points. Okay, those points also have to be same, but now I have to update the line. So curve line, I can do the exact same thing here. Can access the geometry, set from points function, and then use the curve points. So let's see if I did everything correctly. So now I change and the curves changes as well. So that's how you do this function. And of course, there is an option that you maybe want to use another structure here. Feel free to do so, but this seems like a pretty good version. You can also experiment with different colors as well. Maybe make the lines and the points less visible, so the curve itself is more visible. And I'm not sure if the line basic material allows like a wider lines, so that can be also changeable. Okay, I researched it and the line width doesn't do anything, unfortunately, so we can't change the line width. For that, you should create a mesh for the line instead, and then the mesh can be bigger or smaller. Anyway, and I think this wraps up the create spline function, but now we need to create the spline that is C1 continuous. So as you remember from the task description, what we really need to do is shared points have to be changed. So it should be between P2 and Q1 here. And we can do that here in the create spline C1 function with the for loop. So in the for loop, I want all the indices that are the shared points. So let us think what's the first index. It will always be 3, right? Because 0, 1, 2, 3. So we can start with the 3. I should always be less than point length. But voice length, we don't want it to be the last index either. So let's subtract 3 from it, like we did in our for loop in the create spline function. And then we also want to increment by 3 as well, just like in the create spline function. So now we can change the points in this for loop. And here we can use the previous point and next point as well, because I will never be 0 so the underflow is impossible, and the next point will always be available as well, because we start before we end before the end of the point's length. So you can get the last point, and that will be the point at I minus 1. And we can also get the next point. And that will be the next I plus 1. So we want these new points to be exactly in the middle, and how we do it is just get the average of these points. So points at I should be a new vector, and we first copy last point into it. Then I will add a next point to it. So now it will be a sum of last point and next point, and now I want to divide it by 2, so I will use the function multiply scalar. So it will be multiplied by 0.5 or divided by 2. So now it should be right in the middle, this shed point, and if you look at the result as well, it actually is correct. So if I change with the left and right arrow key, you can see this is the C2 currently, because in C2 we don't change anything right now, so it's fine. But we can compare the result. So for the C2, which is actually C0 right now, it's like this, but C1 is a lot smoother because the control point locations have changed. And to get the C2, you should also do exactly the same thing. Instead, you should change more vertices. So we can see here there's this derivatives of the curves, and we want this derivative to be exactly the same, the second derivative to be the same at the shared point. So the shared point, this is 1, this is the end of the curve, and 0 is the start of the curve. So we want the start of the Q to be exactly the same as the end of the P, the second derivative of them. And if we put those to equal and substitute things, we get this equation that's 2 times P3 minus P2. So this is a vector. 2 times P3 minus P2. So where's this P3? P3 is this in the middle of the purple line, and P2 is this. So this 2 times P3 minus P2 is the purple vector here. And this has to be equal to the 2 times Q1 minus Q0. So this will be the purple vector as well, because the Q0 will be the P3. So those have to be equal. But this purple line vector has to be equal as well to the Q2 minus Q1. So Q2 minus Q1 is this red vector here. And it has to be summed with P2 minus P1. This is the blue vector. So if those blue and red vectors are added together, it should be exactly the same vector as this purple vector. As you can see, this goes from this P2 to this imaginary line, and then we add the blue vector as well, and we get to exactly the same place that we would have gotten if we added the purple vector. So that's the constraint on how to get the C2 curve. And here we can see that if we have this big line here, then this tip 1 to tip 2, there are the Q1 and Q2 on them. So we can see that those are the 1/3 and 2/3 between the tip 1 and tip 2. So this will help as well with the constraints. But the end result should look something like this. So P0, P1, P2, P3, and then Q0, Q1, Q2, Q3, R0, R1, R2, R3. Those are already C2 continuous control points. And here is pictures as well of the results. So you can actually compare your results to this picture and see if it's if you have done everything correctly. And also there are links to this PDF as well that you can read about and see what you have to do, what points you have to change, and how you can change them. But be wary that those points here and those indices are different to these. So those are not, they don't have a one-to-one correspondence. So it might be confusing if you don't know this. And if you have implemented this in this Grid Spline C2, and so modify points 2 and points len -3. If you have done this everything here, and also this for loop here, so the apply scale changes for the x and y axis, then the task should be complete, and good luck solving this task.